Testing, testing. Hello. Howdy. Hey, good morning, or afternoon, evening, whoever you are. We are doing more Line 75 LeetCode questions. Again today, coding interview questions. Last time we left off on longest common subsequence, so today we'll do word break problem. 이그소. Alright, word break. Given a string s and a dictionary strings word dict. Okay, dictionary of strings. What do they mean by dictionary? Hash map? Hash string? Oh, in this case, just a list. Return true if S can be segmented into a space-separated sequence of one or more dictionary words. Ooh. Excuse me. Note that the same word in the dictionary may be reused multiple times in the segmentation. Oh. Very tricky. Example 1, for example, S is equal to LeetCode, word dict is equal to LeetCode, output is equal to true. Return true because LeetCode can be segmented as leet space code. Okay, well this looks really tricky. Is this one of those recursive problems that you can be like, okay, I use me, I don't use me, and then cache the results? I'm getting that kind of vibe over here. Alright, let me get out my drawing stuff. Okay, let's think about it like recursion. So I have my function here with string s and with word dict. What's the base case? Base case, if s is equal to nothing, empty string, s is equal to empty string, then return true. Else, for every word in the dictionary, this is out of our base case now. For every word in word dict, if word dict starts with S, I guess, if word dict starts with S, then I return a recursive call function S chopped, where S chop is equal to the string but minus word from the front with the same word dictionary. Yeah, I feel like that's the solution, no? Actually, we don't return this immediately, right? We go through everything. So we make the recursive call, And if it's true, return it. Return if true. Else, if you got through everything, return false. Okay. I'm looking at the second example, apple, pen, apple. Cats and dog. Let me lower my chat so y'all can see this. Okay. I feel like this is the solution, no, but I don't see how caching can help us a lot unless do we actually cache? Like, if we were to cache, would we cache by perhaps S chopped or the current S? But would that help us? I suppose in the case of like, if your dictionary contains, if say this was your dict, right? And it contained leet, and then lee, and then et, and code, and then your word was LeetCode, and then maybe something else in the end. I guess it could help you because you would get code plus the rest, and you would be like, oh, there's two ways of making LeetCode, right? There's leet and then leet individually, and then you would just plus, and you'll be like, oh, automatically code can do it. Wait, hold on. This isn't going to help us, the caching, right? We just need to return true or false. What? We just need to return true or false immediately if we can do it right. So how is caching going to help us? Well, beats me. Time to look at some solutions. Okay, what's this guy doing? Create a set of words from the list so the lookup cost in the set becomes O of 1. Oh, that's a good idea. Initialize the lookup table. Blackbat software. Word. Hi, Blackbat software. How are you doing today? Initialize the lookup table. Is this bottom-up dynamic programming again? Set the first element to true as it represents the empty string. Okay. For int I, okay, from the first letter to the end, for j equals 0, j is less than I, checking if the substring from j to I is present in the word set. And dj is true. Oh. Okay. If dpj and word set dot contains. Okay, I see. S dot substring ji, di is equal to true. If a substring is found, no need to check further smaller substrings. Break. I think he's doing what I'm doing but backwards, right? Is that actually going to help us? Black Bag Software says, I think the millennial version would be fire, lol. Wait, I don't get it. What millennial version? Contains substring J to I. Word is a slang word from the 90s. Oh, I think I heard of that word. I feel like my recursive solution is like this, right? But done forwards? Wait, it's from a song? Word Up? I didn't know it's from a song. Word Up. From Cameo. Did it actually spawn the word word? It's been 10 weeks on the top UK singles chart. Where does the term word come from? Slang come from? Of the slang term word come from? Well, Google is being difficult to work with now. I feel like my recursive solution would work, no? But I'm not sure what the implications of doing it backwards and forwards are. It should be the same, right? I feel like it should be the same, no? Except they're caching the front. And they're working from front to back. I'm caching from the back. Actually, I don't think my caching style would work, right? Because I'm just caching S. Okay, I think I'm gonna try my way, just for a sanity check, but I don't think the caching would be effective at all, but I just want to try it anyways. Okay, yeah, I'll probably try the dynamic programming one after this one. Just want to see if my recursion one would work, and then sanity check that the cache method would probably not work, unless I can change the way. Unless, what if I go backwards myself? I feel like it'll be the same, no? Okay, I'll just go ahead and start implementing. So if s dot size dot or dot length is equal to 0. Then return true for every word, string word in word dict. So if word dict starts with S, is there a helper function in Java that I can use for this? Java string starts with... Oh, cool. Whether a string starts with the specified characters. Awesome, that's exactly what I need. If S dot starts with word, then you do a recursive call, word break with S, but substring. Dot substring. When do we substring from? Let's say we do leet, right? Leet is 1, 2, 3, 4 long, 4 characters long. So then we start at 0, 1, 2, 3, 4 plus 4. 0, 1, 2, 3, 4. Yeah, plus 4. We start at the 4th index. So literally, word dot length, substring, word dot length. Boolean recursive call is equal to word break that. And if this recursive call is true, return true, and else if you made it through everything, return false. Okay, time to submit. That was stupidly fast, which means it probably didn't work, huh? Okay, I'm gonna hide my Chrome window for a second while I sign into LeetCode. I keep forgetting to sign in before these streams. That's my username. This is my password. I'm not gonna say it out loud while I type it in. And we are back. Let's run it. Cannot be applied to given types. I forgot to pass in the word dict in. Comma, word dict. Because hey, my solution was accepted. I still have doubts whether the caching would work though. I feel like we would see everything just once in the cache. Actually, no, wait. The example I just did. Wait, yeah, but I'm so conflicted. What happens if I just submit this? I imagine we would get time limit exceeded, right? Yeah, oh, this sucks. Just caching? Okay, I'm gonna try some simple caching on this. I'm going to take the function here and then put this as a helper function with int what should the key be? String? Yeah, string. So there should be a hash map. String boolean cache. Okay, and then here hash map string boolean cache. Boolean should be capitalized because it's a object version. Is equal to new hash map, and then I call the helper function word break, passing the exact same things in, word dict plus the cache. Okay, back in the cache, we do a if cache dot contains key s, the current s, then return cache dot get s. Was that how you get stuff from a cache again? Get. I feel like we'll never get a cache hit, no? I don't know. Maybe we can test it out. And then here we update the cache. Oh, hold on. Here we update the cache. No, actually, when it's true, we update the cache. Cache dot put current string and true. And else if it's false over here, cache dot put s comma false. Yeah, that's the way to do it. I'm so curious if we get any cache hits. System.out.println cache hit. I'm predicting no. Run this. Boolean should be capitalized. Okay, it's accepted. Yeah, I don't see any cache hits. No, I knew it. What happens if I submitted this? Time limit exceeded. Okay. Okay, I want to try one more thing. So clearly, do we have any cache hits here? Nah. Exactly as I suspected. I am totally a genius. Okay, delete that cache here. Delete the cache. Delete the cache here. No more cache. It's okay, we learned some stuff from here. Delete the cache logic. Delete the cache logic. Delete the cache logic. Can we store our word dict into a set? Hash set string dict hash dict is equal to new hash set from word dict. Is there a constructor like this in hash set? Let me look it up. Java hash set constructor take in list. Oh, sick, it does happen. Cool. Could you not use the constructor? They aren't mentioning this method here. Oh, list object as parameter in hash map. Hash set, I mean. Yeah, makes sense. Looks like you need to add a string here, I guess. Pass in my hash dict here. Hash set. Wait, hold on. Would this help me at all? I feel like it would not. Wait, no. This wouldn't help me at all. Okay, I'm gonna try the dynamic programming solution. Apparently this is too slow. Which is fine, but hey, we did pass some tests, which is nice. Initialize the lookup table. Set the first element to true as it represents the empty string from start of string to end of string. Check if the substring from J to I is present in words. And dpj is true. I mean, this makes sense as a dynamic programming solution, but couldn't we also do this in recursion? For j equals 0 and j less than I, check if the substring from j to I is present in the word set and dj is true. Okay, I think I see what they're doing. So for every single, let's say this is our string, right? let's say we're on here. They're trying to see for every single possible substring, like these, for every single substring, can that be represented with the dictionary? And is what follows a valid word in the dictionary? So is this in the dictionary? And this is kind of like the recursive call, word break. Word break set true. Okay. Wait, isn't it possible to do this recursively too then? So I would start from the end to the front. I guess I would be like, base case would still be s equals 0, s dot size equals 0. But this time I would be subtracting from the back. Okay. Else for I is equal to end to the 0th index, I would be like, okay, is I to end, I'm talking about the string here, is I to end a valid word? Is this a word in the dictionary? If so, if recursive call 0 through I comma the same dict is equal to true, then return true. I feel like that's what I did, no, kinda. Except they did it a smarter way of trying to match. Yeah, I'm trying to match which characters I am using to subtract from. What if I just did that instead, actually? Okay, I wonder what would happen if I tried forward to back. For int equal to I is equal to 0, I is less than s dot length, I plus plus. Okay, current substring would be substring s dot substring from 0 to I if hash dict if word dict that contains the start, then do a recursive call, word break, s dot substring, the substring would be start dot length. Or no, it would be I, comma, to the end, no. Stop length. Okay, let me think about these indices for a moment. So let's say I is 1, no, I is 2, then the start will go from 0 through 1 inclusive. My next will be 2 to the end inclusive. Okay, that makes sense. Would this work? Substring is all lowercase, I believe. It does not work. Let me print out system.out.println. What the start is. String rest is equal to debugging time system.out.println looking into rest. parentheses were wrong. Oh, it did look into what I wanted it to do. Looking into rest, which is code. When it gets to C and then DE, does it not return true here? System.out.println. Huh. It never prints out true here for some reason. Why? Looking into rest code. It never catches the case where code is. It never looks up code. Oh, less than or equal? There we go. Okay, good news. We are accepted now. Not into any fancy institution or anything, but in the first stage of LeetCode solutions. All right, let me try submitting this. Time limit exceeded. Yeah. Is it time to start the caching? Or would caching not even work in this case? And notice we keep starting from the smallest. We start really small at first. What if we tried to look for the biggest start we could at first? We could probably save a lot of time here. 35 of 47. What if instead of starting at 0, we started at s.length instead? S.length minus 1, while I is greater than or equal to 0. I gotta be careful with my bounds here. I minus minus. So start string is equal to s dot substring from 0 through s dot length. Okay, so then we can chip away at it faster, hopefully. Let's first run this. Could not compile. Oh, I forgot the parentheses. Okay. Well, we still didn't pass this one. I feel like it would chip away at this one faster though. No? Okay, I'll revert my stuff. Alright, start caching? Sure. Hash set, string, hash map, string, boolean, cache is equal to new hash map. Pass that into here. Pass that into here as well. We look for a cache hit. If cache dot contains key s, return cache dot get s. Cache dot put s comma true. Over here, cache dot put s comma else. We need to update our cache here as well. All right. Let's go. We beat 50%. Okay. So I guess the cache does help, huh? So in the case where it was a bunch of like AAA, I guess we might exit quickly, like more quickly out of certain combinations if we see like, oh, the remaining string I have looked at before and it doesn't work. Yeah. I also think what sped it up was also the converting the word dict into a hash set. Yeah, that may look up time a lot faster. Probably looking for the start by index, like slowly increasing I, maybe a bit faster than just going through your entire dictionary and seeing if it matches, I guess. Is it that much faster? Because then it's, if you do it this way, then it's O of n, where n is the length of your string. If you do it for each, entry in the dictionary, it's nm time, right? Where n is the... Wait, hold on. Isn't it about the same? I'm thinking it was nm time. Because where m is equal to number of dictionary elements you have, and n is the length of the string. Yeah, because string that starts with probably uses n time, right? Roughly. It depends on the length of the string, nm time. And if you tried looking up the elements like this, you're using a hash map. Oh, so it's O of 1 time for each lookup. So it's just n time. I see, that's why this is faster. Dang. Maybe I should make a note of this. O of n lookup versus O of nm for every dict entry. Can I submit this again to record my finding? Alright, cool. I will also record this problem down. Called word break. This one actually wasn't that bad. I think I kind of got it in the beginning. Okay, let's move on. Let's go to combination sum. Combination sum IV. Given an array of distinct integers nums and a target integer target, return the number of possible combinations that add up to target. The test cases are generated so that the answer can fit in a 32-bit integer. Okay, good to know. I feel like we can break this down into a recursive problem too, no? Function, we get our nums and the target. The recursive case would be function the number of possible combinations that add up to target. Okay, so for every num in nums, do a recursive call. F, given an array of distinct integers, can I repeat numbers? Oh yeah, looks like I can repeat numbers. So I would still input the same nums. And the target would minus my current num. Yeah. What's the base case? Base case is target is equal to 0. Return true. Wait, I'm worried though. What if my actual problem was like 1, 2, 3 and then target is 0? Then there's no solution. No, we're screwed. What could the target equal? Oh, okay, look. Target is between 1 and 1,000. So we're good in the base case. Dragon says, yo, how's the interview? Hey Dragon, how's it going? How's your day going? So, I had 2 interviews yesterday. Yesterday was exhausting. First interview went well. Second went not so well. I think I can explain. I can like tell you guys about what happened in the interviews. Let's see. So for the first interview, it was a LeetCode interview. Yeah, the interviewer was so nice to me. He actually arrived like a few minutes late, so we started a bit late. He gave me like a string formatting question. He gave me like a sentence, and I had to break it up into multiple lines depending on what the max words per line is, and then add spaces in between the characters to fill up to the max words, max characters per line, and then format the end line in a specific way. It was like a not so bad problem. It was just really tedious. And I remember the interviewer got so, like both me and the interviewer got so on edge and excited in the end because I was running so low on time. But I was so close, and he even started like pointing out edge cases to me, like, oh, you're so close. We're running out of time, but you're missing that edge case and that edge case. And then when it was like 5 minutes left, I still had like 3 edge cases that were not passing. They gave me test cases to run my code on. And then in the end, he kind of just gave up on me, and he was like, okay, you know what? We're running out of time, but maybe you can just say what the solution is. I'm not sure if you'll pass that way though. And then I managed to add a random add statement in one of my if statements. And then I plugged into the code and I ran it, and it passed 100%. And then we looked at the clock and it was like 3 minutes past. It was 3 minutes past the allotted time slot though. But, so I wasn't sure if I passed then. But the interviewer was like, you know, I arrived 3 minutes late. You finished 3 minutes after the allotted time. I'll give you it. He was so nice, dude. He let me pass. I think that was fair though. If he arrived 3 minutes late, I should have 3 minutes more time, right? So yeah, he was super nice and super fair. And I liked how he got really invested into, the problem and me in the end too. Like, I felt like I was working on the problem with him at the end. He's probably like, dude, this guy is so close, like so painfully close. Might as well just push him over the edge. So that went okay. Yeah, I did ask him if it counted as pass because I went over time 3 minutes, but yeah, he said yes. The other interview of the day was this was the one which I was practicing for, the object-oriented design one. You know how I was making all those jukeboxes, parking lots, and whatnot the past few days. This one did not go so well. I don't know if I was like just tired from the previous interview, or just too nervous. They asked me to design a ride-sharing app, basically, and I completely just brain froze. Yeah, I think I mustered out a driver class and then a passenger class. What else did I do? I kind of forgot what I did. I had some data structures to contain all the drivers. Yeah. But yeah, I didn't do too well on those. Dude, things keep popping up in memory. Like, I keep realizing in hindsight that I should have done better there or there. Like, at one point, the interviewer was like, we are a analytics company, so we want a way to log all the different performances of the rides and the drivers. We want to reward what the best drivers are, whatnot. And in hindsight, I realized that he was asking me to make a ride class so we can log it. Make a ride class, maybe a start time and an end time. A ride sharing, he wanted me to make a ride sharing app, but with like a terminal interface, just like a bunch of objects, but with methods that you can run in the terminal to run the app. Yeah, I thought it was kind of complicated. So there were two parts to the app that he wanted me to make. One was he wanted me to have a system where I choose 2% of all the workforce to be the driver for the day. So I need a random selection system for all the drivers. And then I need a system to assign the passenger to the nearest driver. Yeah, I don't know how to do the second question at all. Really beats me how Uber does it. What I did was I basically had a really brute force solution, unfortunately. I had a list of all the drivers, and each driver had a location parameter. So for every customer that was requesting a ride, I unfortunately had to go through all the drivers and see which one was the closest to the passenger, which is, I don't think it's ideal. To this day, I probably need to look it up after this stream or whatever. I was actually trying to look up how Uber does it, their ride matching algorithm. I don't know, I couldn't find any good info on it. I can't tell if they represent their entire world as a grid, or like a graph. So they would just do breadth first search for every single customer. That sounds like a hassle though. They expect me to represent the world as a graph for just a 1-hour interview. Another thought I had though was, what if I just divided the world into like realms or like districts and keep track of which district the driver is in. So for each passenger, if they request a ride, I would be like, oh, I'm in this district right now, or this realm. Maybe just search, like linear search, in the list of drivers in this realm, which one is the closest to me. But yeah. Dragon says, I'm not sure about system design too, but I started reading Alex Shu's System Design Interview first book. Oh, I've heard of that book. I'm actually reading another different book on system design called Designing Data-Intensive Applications. I've heard from other engineers in the industry that that's a good book. Wait, does Alex Shu's book contain problems that you can do? Because I don't see any problems so far in the book that I'm using. Alex Shu's... Oh, I'm using one called Designing... here, I'll type it out. Designing Data-Intensive Applications. This one. From what I can see, it's basically a bunch of data storage, or like backend mostly. How to process data in the backend, like caching, Should I use SQL, no SQL? Yeah. That's for back-end engineering mostly, I think. Alex Shu's system design interview. I don't know. I might try this book too. I have been. Does this contain like example questions? I feel like my book is just all reading. Example questions? I see. I might give this book a go actually. This seems more like interview based. Mine is like, I don't know, back-end engineering based. Yeah. But yeah, it's fine. For the second interview, I guess I learned some good lessons. I feel like I actually should have asked him, like, what did he actually expected me to implement everything, like a working console version? Because halfway through, he told me that I just need to do a rough outline of the classes and not, because I actually started implementing the random driver selector, and he was like, okay, you can just do a helper function for that, and we'll assume that it works. Yeah. I should take cues from the interviewer better, I think. He was definitely trying to hint for me to make a ride class in the way he talked about analytics. But yeah, it's okay. There is always next time. Okay, back to the problem. Combination sum. Return the number of possible combinations that add up to target. Note that different sequences are counted as different combinations. Oh, hey Anshul. Which book? Oh. So I'm reading this one right now. Dragon is reading Alex Shu's book. So I'm reading Designing Data-Intensive Applications. Dragon is reading Alex Shu's book. System Design Interview by Alex Shu. And it's so funny. I used to have a classmate actually called Alex Shu. So I keep picturing his face whenever I see by Alex Shu, like, wow, he really made it in life, huh? Wrote a best-selling book. Anshul says, I have also started preparing to switch my job eventually. Anshul says, I'll start with Alex Shu. I think the name suggests it is oriented for interviews. I see. Yeah. I get the vibe from the book that I'm reading so far. It's not really it's kind of for practical applications for back-end design. Yeah, maybe I'll give Alex Shu a shot. I really didn't think this book helped me at all in the last interview. More like CLRS for system design. What is CLRS? CLRS. The book you're reading rated as Tier S. But it didn't help me so far in the interview. Maybe because I'm on chapter 2 too. I feel like that it's more like real world application. Maybe in some interviews they'll ask me questions about that. Okay, let's get back to the question. So if target is equal to 0, then I shouldn't return true. I should return 1, because that means I succeeded in adding to it 1 time. I'm really worried what would happen if I get duplicate combinations. Wait, duplicates are allowed. 1, 1, 2, 2, 1, 1. Huh. Nice. I guess order matters. I'm gonna try my current solution over here. Oh wait, hold on. I should also keep count of how many of these are actually true. Return count. That sounds like a plan, no? Dragon says, you can solve n queens, you can solve this too. I mean, thanks for the encouragement. I did have to look at the solutions for n queens though. It was hard. Okay, let's try this one. Base case. If target is equal to 0, that means I successfully added to it, return 1. Else, for every single num in nums, I do a recursive call. Int count is equal to 0 by default. If the count plus equals a recursive call to the same nums with the target minus the num. I think that works. And then return count. I am so paranoid right now. It can't be this short, right? It's a medium question. I'm probably missing something, to be honest. Should I add this case? If target is less than 0, return 0, because that's not a way. Okay, I predict we don't have it right now. You gotta be joking. Really? Okay. So for this to be a dynamic programming question, we need to add caching too. Wait, this was surprisingly short. Okay, hold on. Let me submit for a sanity check too. If we got it right, then we should see time limit exceeded. Time limit exceeded. Okay, so all we need to do is add caching now. Okay, very cool. Let's add some caching. I thought it was backtracking. I mean, I found this on the dynamic programming section, so I think you could do backtracking too. Yeah, it should definitely work. This just feels like a backtracking question too. Backtracking will... Oh, time limit exceeded too? Can you cache with backtracking too? I don't know. I'll just proceed with what I'm doing. Okay. We need a cache. What do we store in the cache? The target? Yeah, the target. Is it a good idea to target? Cache plus backtracking equals dynamic programming for me. Actually, yeah. Yeah, that's probably DP. Wait, recursion plus backtracking is also DP, so that's probably DP too. I'm trying to think what we should use it as a cache. Should we do like a int array, but it's like target, the size of target? That seems really inefficient for storage, but I know that int arrays are faster than hash maps. In Python, just one line. Yeah, the add thing, right? I think you showed me last time. I think it's more efficient if we stored it as a hash map. What if target is like super huge? Hash map. Yeah, hash map. Integer, cache is equal to new hash map. And then we insert it into our helper function. Return this with nums target and cache. We also need to insert our cache into the parameters here in the helper function. And then we need to cache we need to check for cache hits. Else if cache contains key the target, we return the cache value. Return cache.get target. Over here, we cache.put the current target and count. Okay, let's see how many compilation errors I have. Oh, I forgot this. I also need to re-enter the cache in the recursive call here. Reggie says, hi, how are you doing? Hi, Reggie. I'm doing good. Yeah, I got through another round of interviews yesterday. I feel very relieved today. Hey, Reggie, how are you doing today? I'm very curious, is the cache actually getting hit over here? System.out.println cache hit. Hope you guys are having a good day too. Oh look, cache hits. Very nice. I hope we don't get another. Let's go! It worked! Dude, I feel like this is the first problem in a long time that I didn't need to look at the solutions. Does this mean I'm improving? Or is this just a really easy question? Am I gonna get a faster time if I submit again? Oh, same time. It's fine. But hey, I feel like I was pretty autonomous for this question. Next question. House robber. This sounds like a exciting question. Reggie says 1. What's the 1 for? House robber. You are a professional robber planning to rob houses along a street. I like this question already. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if 2 adjacent houses were broken into on the same night. That is a goofy ass security system. Reggie says, is this the yesterday question or a new one? Oh no, all of these are new questions today. But I feel like combination sum used some knowledge from previous questions as well. So yeah, I may have been able to do it much more quickly because of that. It will automatically contact the police if 2 adjacent houses were broken into on the same night. Right, because it's not alarming at all if every other house is broken into. But if 2 adjacent houses are broken into, now that's a security concern. Given an integer randoms representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Alright. How the heck do we do this? Dragon says, finally, very famous LeetCode DP problem. Man, how do we do this? Sounds complicated. So I cannot rob adjacent houses. LeetCode taught us how to rob a house smartly, says Dragon. Wait, yeah. Can you put yourself into the shoes of this robber right now? Like, yo, I have 2 options in life. I can rob this street with a really goofy security system. A system so goofy that I have to write a computer program to decide how to rob it. Or I can get a job as a software engineer. Nah, I think I'll rob the houses. Reggie says, do you also do SQL questions on LeetCode or anything related to DBMS? Oh, I've never tried SQL questions. I actually did not even know LeetCode has SQL questions. LeetCode, SQL. Wow. Yeah, I did not know LeetCode has SQL specific questions. I've never... maybe it's because the positions I'm applying for too. I've never had to write SQL during an interview before. Dragon says I skip all SQL. But yeah, SQL is a important language to learn though. A lot of querying stuff is based on it. So MySQL is very popular. Okay, let me get the drawing tablet out. I'm trying to think about how to do this. Rob houses along a street. Each house has a certain amount of money. So we're given like 1, 2, 3, 4, 5, 6, 7. Reggie says, what type of questions you got asked during your interview? Oh yeah, I was chatting with Dragon about this a little, but I basically get LeetCode questions. The types of LeetCode questions I've gotten so far are linked list questions, trying to find a loop inside of a linked list. I've gotten tree questions, like trying to depth first search them and adding up all the nodes with sum of nodes with values between a certain range. I've gotten string manipulation ones where I was given a sentence and I had to break it up into lines of maximum lengths and then pad the words with spaces until it added up, each line added up to the desired lengths. I've also gotten system design questions where they asked me to design like a mini Uber app, which I did not do well on. I straight up panicked during the interview. It was such a big question. But yeah, mostly LeetCode-ish questions so far. Trees, linked list, string manipulation, that kind of deal. Dragon says the Odin project updated their syllabus to let us learn SQL. What's the Odin project? There's so many resources I haven't heard of. But yeah, thank you guys for posting resources in the chat. Oh, I definitely think I might switch to Alex Shu's system design book instead of the one I'm reading right now. The Odin project. The Odin project. Full stack JavaScript. Oh. This is cool. I'm actually learning HTML, CSS, and JavaScript on freecodecamp.org. I don't know. What do you guys think of this thing? The Odin project is deeper. I done FCC. So this is deeper, huh? Yeah, I thought the HTML and CSS course on FreeCodeCamp was pretty good. I finished that last week. Yeah, for someone who's not good at that at all, I thought I did a pretty good job. The JavaScript course right now is really slow for me right now. They're like going through they're kind of taking it really slow, just going through all the JavaScript syntax and stuff for 2 projects before doing DOM stuff. Okay, yeah, maybe I'll take a look at this. Thank you for the suggestion. I will take a screenshot of this. Okay, back to the question. I honestly have no clue how I would do this right now. But I guess we can... Reggie says, yeah, it's really slow. Okay. I guess if we can break this down into a caching / recursive solution. Let's say I rob this house, right? Then I guess I can recurse on the rest here, but I can't do this house. Should I have a way to track which houses I've already been into? I feel like that's a really good thing to have. Or should I just should I put the nums into a linked list instead and just remove houses that I can no longer access? for each recursive call. Dragon says 5, 4, 6, I think. Put into LeetCode test case to see if it gives 5 plus 4 plus 6. We can't rob adjacent houses, right? Okay, let's do 5, 4 plus 6. 5, 4, 6. The answer will be 11, right? Oh, they don't tell me what the expected amount is. But here we're robbing 1 and then 3. Oh, you meant test case of this. Oh, I see. That's what you mean. Returned 0. Hopefully they will give me the answer. 4. Oh wait. 15. Yeah, 15. Yeah, I'm trying to... Should I put everything in a linked list and then just for each recursive call remove the houses that I can no longer go into? Like for example, if I go into 1, then I would cut off 1 and then 5 and then plug this into the recursive call. Is it worth the hassle though of converting everything to a linked list? That sounds like a hassle. Or I can do another Boolean. I can do another Boolean array that I pass into my calls and then mark down which ones I have been into. Try drawing a decision tree. Okay. Oh my goodness, this is gonna be a big decision tree. Let's do a simple case, yeah? Let's do 1, 5, 2. So let's say I go into 1. My only other option is 2. Let's say I go with 5 here. I mean, I can only go with 5. Okay. Okay. I'm thinking about passing just a Boolean array down. That's better than doing a linked list, right? I feel like that's way less hassle. Okay, so let's say I'm at 1, right? I'm like, okay. Let's say I use 1 at first. And I go here to the next call and I'm like, okay, which of these could I possibly use next? And I'd be like, oh, I've already used 1. Can I use 5? And I check its neighbors. Dragon says linked list and DP I haven't heard of. Maybe I'm noob. Yeah, I was thinking it sounds like a hassle too. But I like the idea of passing down a Boolean down. Okay, here's what I'm thinking of. What am I thinking of? I'm so confused. Nums, what's my base case? What's the stopping case? How do I tell I've gone to all the houses possible? index adjacent houses have security systems connected, and it will automatically contact the police if 2 adjacent houses were broken into. Should I use an index again? Oh, is this another, like, do I use me or not problem? I see, index. Let's try going with index. So base case, index out of bounds, return 0, wait. Yeah, return 0, right? Return 0. Or is it return 0? That means I have no more houses to rob. Okay. So the question is, for these type of problems, like, do I use me or not? Do I use my current index or not? Let's say I use Wait, I swear I've seen this type of problem before. Let's say I use me, right? So the value of my money would be current house value plus n recurse nums and index plus 2. Yeah, index plus 2, right? Because I can't use the house directly next to mine. Or if I don't use me, I can use the one directly next to me, right? So I don't use me, so I don't get any value out of me. So nums index plus 1. I can use the one right next to me. Yeah, I feel like this is the plan, no? Can you guys even see what I'm writing? Oh, you guys can. And then, yeah. I guess we can first do this, right? And then worry about caching later. I like this. Okay, let's go. This is definitely a helper function because we have extra parameters. Okay, int index. Base case. If I is equal to, or if I is greater than or equal to nums.length, return 0. Wait, hold on. The outline of this doesn't actually answer the question, yeah? We returned the max of, I don't have my tablet anymore, I put it away. We returned the max of these. Okay, yeah, that's the plan. Now in the case where we use me, int use is equal to recursive call rob nums I plus 2 and my value currently nums I. Else, if I don't use myself, int no use is equal to rob nums I plus 1 Okay, and then return math.max, use comma, no use. These comments are kind of redundant. Okay, let's see how much I screwed up this round. This looks way too simple. Surely I'm missing something, right? Oh, I'm dumb. Return Rob nums 0. Oh my god. It was accepted. Let's go. Okay, sanity check, let's submit. If it works, then we get time limit exceeded. And if it doesn't, we messed up somewhere. Yeah, time limit exceeded. I've never been so happy to see an error message. And we passed 55 of 70. Well, yeah, this is surprisingly simple. Time to add caching. Our num stays the same on every recursive call, right? It's just the index that's changing. So we'll cache it. Yeah. Okay. We'll just do an int cache is equal to new int just with nums plus 1. Wait, nums dot length. Do we need a plus 1 here? Or whatever. 1 won't make a difference. So yeah, index will go from 0 to nums dot length. That's perfect for me. Else if we need to arrays.fill this too. If arrays, not if, just arrays.fill cache comma -1 cache I is not equal to -1. Return cache I int result is equal to the thing below. We will need to cache this. Cache I is equal to the result. Return the result. Enter the cache here too. Enter the cache. Enter the cache. Enter the cache. Am I missing something? Or just give it a spin? Oh. I forgot the type here. Forgot the cache again. Oh, I inputted the cache in the wrong spot. There we go. I beat it 100%. Let's go. Man, today is a good day. Maybe the world is rewarding me for doing so trash on the interview yesterday. They're like, let this man have a win for once. Well, I just did that one on one of 2 interviews yesterday though. Hey, awesome. So we did house robber. We did word break, combination sum, and house robber today. It's almost 11 o'clock. I think I'll call it a day here. Alright, let's end on a happy note now. Alright, thank you Dragon for sticking to the end, I appreciate. I forgot who was here too. Anshul? Yeah, Anshul was here, thank you. Blackback was also here. Thank you. Bye, guys. Have a nice day. See you tomorrow. Oh, wait, I'm actually streaming at 2 p.m. today. I'm gonna do a HTML practice stream. Yeah. Alright, bye. See you.